Hello, 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 all our lovely grade 11 mindsetters. Welcome to the grade 11 mathematics show today with myself, Queen Matusa, and of course, as always, I am not alone. I've got an awesome studio teacher here with us today, Dina. How are you, Dina?
Hello, Queen. I am very well and glad to be back with the grade 11s.
It's good to have you back, Dina. Now, guys, remember that this show is all about you. So please connect with us on our different social media platforms. And you can find us on Facebook at Mindset Learn Extra, or you can find us on Twitter, and that is at Learn Extra with an X. Remember, don't forget the X. Or you can also log on to our website at learn.mindset.co.za for all your notes and any other extra resources that you guys need for yourselves. And guys, remember that we've got our competition that is still running. In order to win yourself an awesome Sony Xperia L phone, all you have to do is log on to Curio and register and simply like your favorite mindset teacher. And then once you're done there, you can also come onto our Facebook page and like your favorite teacher's photo on our Facebook page. So it is easy and simple as that, and get yourselves in that competition in order to win yourself this awesome Sony Xperia phone. And we've also got airtime up for grabs, so we just love you guys. We've got so many prizes, so don't miss that opportunity. But with all that being said, let's get straight into the show. Dina, what do you have for the grade 11s today?
Well, with the grade 11s, we're going to be looking at some trigonometry, especially some very, very useful trig. Up to now, you may have thought, where am I ever going to use this trigonometry? But this kind of trig helps us to find sides, lengths of triangles, as well as angles in non-right angle triangles. So in grade 10, you all looked at how to use the SOHCAHTOA rule. Well, now we are going to use some rules that are going to help us to find angles and sides of triangles.
Wow, that seems very interesting. So let's not waste any time.
Great. Challenge question is up on the page, eh?
Yes, we've got our challenge question. Don't forget to look at that and get your brains working and see if you can get the correct answer. And then we'll give you guys the correct answer towards the end of the show, right, Dina?
Yep, definitely. Right, grade 11, so we're going to get started straight away with what the aim of our lesson will be. What tools do we have available that will help us to solve non-right angle triangles? And when we talk about solving a triangle, we're specifically talking the lengths of the sides and the size of the angles. That's how we solve a triangle. Under what conditions would we apply the sine and the cos rule? The fact that the sine rule is the ratio of the sine of an angle over the opposite side, the cosine rule, which is that formula, and then finally using the area rule. So those three rules are the tools that are going to enable us to solve for triangles. The challenge question is up on the page, and we've got a very interesting context. We have a point P that is above sea level. We've got Q and T that are points that are in the same horizontal plane, and then we would like you to be able to work out certain distances on this picture. A really fun contextual problem that I'm sure for those of you who really enjoy a challenge, here it is, grade 11s. Try it out, and in about half an hour or so, we'll be able to do it with you as well. Okay, we're going to start off with the cosine rule. And the cosine rule really reminds us a little bit about Pythagoras, because if you look at what it says, it has a squared is equal to b squared plus c squared. Now that certainly gives us some memory about Pythagoras. And then it's got this term minus 2bc cos a. Now the cos rule works like this. If you have the length of the side, it will be opposite that angle. So you'll notice here there's b, and there's b, and there's c, and there's c as well. So that is the formula. Grade 11s, these formulae will be on your diagram sheet, but it's good to know where and how these rules actually get used. So the cos rule is useful when we would like to find the length of a third side. So we would like to know how long is a third side in a triangle if we are given the length of two sides and the size of the included angle. So if I have a situation where my angle, let's draw it over here. If I have this side, and I have this side, and I have this angle, what the cos rule allows us to do is to find the third side in the triangle. So we are looking for specific information in that triangle. Then, the other thing that it's very useful for is if we've got the length of all three sides, we are able to find one angle. Now, grade 11s, just imagine, up to this stage in your lives, if you had a triangle with three sides, you would have to go and measure each of the angles by construction with a protractor. For the first time, you are able to go and calculate that angle by using a formula. And I know this for the science students, when you're working with vectors, this is going to be very useful for you as well. So we are going to be able to find an angle if we are given SSS. So if we are given that side, and that side, the formula will allow us to calculate one of those three angles. Okay, so very, very useful rule. So how does the sine rule work? Well, the sine rule is a set of ratios that exist in a triangle. So if we have a look at this set of three ratios, it has sine A over A, sine B over B, sine C over C, or A over sine A, B over sine B, C over sine C. Those ratios are equal as well. So we are saying that if you take A and you divide it by sine of A, so the information must be opposite each other, then that will equal that ratio, which will equal that ratio. Very powerful fractions that we are using to be able to find information. Now, when I go up here, when do we will apply the sine rule if we are given a side and two angles, or two sides and an angle, but the information must be directly opposite each other. So the angle and the side must be opposite, facing each other. Otherwise, if we have two sides and an angle where the information isn't opposite each other, we're not going to be able to use the sine rule. So I would always like you to work with side angle, side angle, side angle, the information opposite each other. And then finally, we have a area rule. Let's just go back to the area rule that says that in any triangle, if I don't, up to this stage, you have worked out the area of a triangle by using a perpendicular. If I don't have a perpendicular, I actually can use the formula half AB sine C. So if I have C here, and I have side A and side B, then what I'm saying is I can calculate the area of that triangle if I have an SAS arrangement. So a side, the included angle, and the side, then the area of my triangle is given by that formula. So we're going to be able to work out areas of non-right angle triangles. Isn't this absolutely fantastic and very, very useful? So let's go into our first question. We would like to work out the length of AB. Now, if I look at AB straight away, I position my finger at the angle that's opposite that. This is the side that I need, and I can see that it's facing the 24 degrees. I can also see that the 7 that I'm given is facing the 62 degrees. So because the arrangement of the information is facing each other in an opposite direction, we will use the sine rule. Okay? We can't use the cos rule because we don't have three sides and we don't have SAS. So cos rule only SAS or SSS. But the sine rule is when the information is opposite each other. So grade 11s, the sine rule, how does it work? You can always start with what you don't know, and we don't know AB. So we will start with AB. So AB divided by the sine opposite the angle of AB is C, sine C, would equal to AC divided by sine of angle B. So that is the information that I'm given. Notice I on purpose have used AB, what I don't know, first, so that what I'm solving for is going to be in the numerator. It's not going to be sitting in the denominator. So now I substitute in the values. So I get AB is equal to AC, I know, is 7. I'm dividing it by sine of b, which is sine 62. And then I'm taking that across and I'm multiplying it by sine 24. Right. And now I just use my calculator to use those. Let's just see, it's here. We've got 7 times sine 24. And we are dividing it by sine of 62. And we get 3,22. So AB is equal to 3,22. Okay. So that was the length of AB using the sine rule. Just see if we've got the other question following up, or if we go right. Now we need to calculate the length of angle Q. Again, if we look at the position of the information, I need to find this angle. Look at whose opposite angle Q. It's this length PR. And look at the given information, side 15, and its opposite 104. So when the information is opposite each other, we can create the sine rule. So we have what I don't know is sine Q. So start off with that. I don't know Q, so I'll start with sine Q. He's found opposite PR, and that will be equal to the other pair of angle side, which is sine P over QR. Now you can substitute, and we've got a very squiggly line, QR. Right, now let's substitute. Sine Q, I don't know what it is, but I do know sine P, that's sine of 104. And I'm dividing that by QR, which is 15. And I'm now going to take PR across and multiply by that, which is multiplied by 8. So I'm going to multiply that by 8. Right, I take my calculator. And we have, let's clear that, 8 times sine of 104. And we're going to divide by 15. And we're going to get 0,51. Now remember, we're trying to find sine Q. So sine Q is equal to 0,51. That doesn't give me the angle, that gives me the ratio for sine Q. So if we look at what the angle of that answer is, that gives us 31,16, so 31,2 degrees. So Q is equal to 31,2 degrees. Okay, grade 11's very powerful tools for calculating the size of angles. Notice non-right angle triangle, it's an obtuse angle triangle, and the information is facing each other, so we can use the sine rule. So sine rule useful for when the information is directly opposite each other in that diagram. And I think, Queen, it's time for us to take maybe a little break or some questions.
We don't have any questions yet, but I'm sure you guys can work on your questions that you have, if you have any questions based on the work that we've done so far. But for now, let's take a quick ad break, then we'll see you guys after this. Welcome back, grade 11s. Now, you guys seem a little bit too quiet on our Facebook page over there. What's going on? The challenge question, guys. Come on, get tackling. We want to see if you guys are actually grasping your trigonometry at school. But without saying anything further, let's get straight back into the show. Dia, can you take it?
Grade 11s, how's that challenge question doing? Peace, 993 meters above sea level, and we've got A and B that are certain heights above sea level. Have you been able to work out what AT is yet? Have a look on the page. Let's get going. You've got another 15 minutes, and then we'll have a look to see how good you've been. But I think we want to see those answers posted. Queen is waiting for you, so let's get going. Right, grade 11s, we've looked at the sine rule. We've looked at how it applies, how to use it, which conditions, under which conditions we need to use it. And we now want to look at a case where we would use the cosine rule. Okay, we need to calculate the largest angle in the triangle with all three sides given. So if we have 7, 4, and 9, grade 11s, where would the largest angle be? Where do you think it would be situated? Would it be angle Q? Would it be angle R? Or would it be angle P and Y? Okay, if I go back to what you did in grade 8, you will have remembered that if we have a right angled triangle, where is the largest side positioned? Yes, you've always said it's the hypotenuse. Why is that so? Because this angle here is going to be acute, and this angle here is going to be acute, and both those angles are opposite those two sides, which will be shorter than the hypotenuse because the hypotenuse lies opposite the 90 degree, which is the largest angle in a right angle triangle. So there is this beautiful relationship between the size of the angle and the length of the sides in a triangle. The larger the angle, the larger the side opposite that angle. So we have on this diagram here a side 4, a side 7, a side 9. So we automatically say, hang on, the biggest angle is P. The smallest angle is R because it's opposite the smallest side. So the question's really asking us to find what is P. Now, let's look at the position of P in relation to the diagram. All four sides are equal. SSS is a condition under which we can apply the cosine rule because we've got all three sides. So how does the cosine rule work? In grade 11s at the outset, you're going to have to refer back to your notes, but it's always the side opposite the angle first. So it would be QR squared is equal to the sum of the other two sides squared. So it's PR squared plus PQ squared. A little bit of Pythagoras. But then we take away the product of twice PR times PQ times cos of angle P. Okay? And with that, we then have a substitution that can happen. So we have a 9 squared, we have a 7 squared, we have a 4 squared, and we have a minus 2 times 7 times 4 times the cos of P. And once you've got that, you now need to solve for cos P. So we need to get rid of these terms here. 9 squared minus 7 squared minus 4 squared divided by negative 2 times 7 times 4 is equal to cos of P. Notice that I didn't use the cos P formula because it just means another formula that you have to learn. So it's nice just to always apply the cosine formula and then solve for the one term or the one factor that you need to solve for rather than having a variety of formulae for the cosine rule. So we can now use our calculator. We have 9 squared, which is 81. We're taking away 49. We're taking away 16. And we're dividing that by 7 twos, 14 fours, or 28 twos is negative 56. So we get negative 2 sevenths. And we'd like to know what angle does that give us. 106,6. That's fantastic. So we have cos P was equal to the ratio negative 2 sevenths. And if you look for the angle, P was 106,6 degrees. Great. So we can find an angle. Okay, now we would like to find some areas. How to use the area rule. We would like to find the area of this triangle. It's isosceles. And yes, we are able to find this in a number of ways, but we'd like to use the area rule just to help us out here. This triangle PQR is isosceles, so we know that this length is 6. If it's isosceles, then the angles opposite the equal sides are equal, so that's 48. And we then have that double 48 is 96. So therefore your apex angle is 180 minus 96, which gives us 84. So this angle is 84. We've now created a situation where we have, watch carefully, side, angle, side. With an SAS arrangement, we can use the area rule. How? It will be area of triangle PQR will equal to half of the two sides, so it's 6 times 6, multiplied by the sine of the angle between them. And then we just need to find out what the sine of that is, sine of the answer, and we're going to multiply that by 36 halved is 18. So we're left with 17,9. So the area is 17,9 squared centimeters. Okay. So the important thing with an area is that we want the arrangement side, angle, side. And with the current information, just 6 and 48, that wouldn't help because my angle wasn't included. It's got to be adjacent. The angle's got to be adjacent to both given sides. Okay, what about the equilateral triangle TRY? Well, what do we know about an equilateral triangle? Levins, what can you tell me are the features of an equilateral triangle? All three sides are equal, equal sides, and all angles are 60 degrees. So let's put that information on the diagram. Each angle is 60, and each side is 4. So is it easy to use the area rule? Yes, because if we look at it, we can take this side, I know is 4, the included angle is 60, and the other side is 4. So the area using SAS would be a half of the two sides multiplied by the included angle. And so we get 16, half of 16 is 8, times sine 60 is 4 root 3, which is 6,9. So the area is 6,9 squared centimeters. So our whole solution process for the area is always to look if I have an arrangement of the side, angle, side, because then I can find the area. If not, I need to go and find those sides before actually applying the formula. What about the following shape, this parallelogram? What is the area of the parallelogram? Well, we have got a formula for the area if we have a perpendicular. So without the perpendicular, we can see very easily that I have two shapes here. I've got this shape, and this one is exactly the same area as that one. So if I can work out the blue and double, I've got the area of the whole shape. What do we know about the properties of a parallelogram? Its opposite sides are equal. So I've got 4 on the side. So if I look at the information, I have side. Let's just undo that. Let's put it in there, right. I've got side, I've got angle, and I've got side. So I can say that the area of triangle ADB is equal to a half of 4 times 5 times the sine of the included angle. And that gives me a half of 4 is 2, 2 5s are 10, 10 times sine 120. So sine 120 times 10 gives me 5 root 3, but that's the blue triangle. So if I times that by 2, I get 10 root 3, which is 17,3. So 5 root 3, which means that the area of the parallelogram is twice 5 root 3, which is 17, what did we say that was? 17,3. And it's in squared centimeters. Right, now I think you've got a good idea of how to use that area rule. We need a side, angle, side information given. And if we're trying to use the cosine rule, then we need side, angle, side, or side, side, side to find that third angle. And then with the sine rule, we just need to have the information that's lying opposite each other. So I would have a side, I would have an angle opposite that. I would have another side, I would have the angle opposite that. I would have another side, I would have the angle opposite that. And if I have that orientation, I'm able to then use the sine rule. Let's now move to one of those examples where we put everything together. So we've done them as individuals. Let's put all the information together and see how we can manage that. Okay, we've got trap is a trapezium with TR parallel to PA, and we need to calculate the length of PR. Now, if I identify PR, here's my PR. Now, PR is inside this triangle. It's also inside that triangle. And I would use the information in this triangle because notice where PR is positioned in relation to angle T. It's opposite that, and I'm also given side, angle, side. So in this triangle here, I've got a side, angle, side, so I can use which rule to find PR? Side, angle, side is the cosine rule. So let's use the cosine rule on length PR. So PR squared is equal to the other two sides squared. We're going to square the other two sides, and then we're going to take away the product of that two sides, and we're going to multiply it by the cos of the angle that's opposite PR. So the information always works in opposites. T and PR must be opposite each other. Okay, we've left the diagram behind, so let's take TR squared and PT squared. So it's PT squared plus TR squared minus 2PT times TR times the cos of T. Once you've written down the information with relation to the triangle that you're working in, you can now go and substitute in values. So we have 10s and 6s, and we've got 116. So PR squared, that's what we're trying to find, is 10 squared plus 6 squared minus 2 times 6 times 10 times the cos of the angle that's facing that PR. And then we A4 away with our little machine, our magic machine here. We've got 100 plus 36 minus 2 6s are 12, 12 10s are 120, so that's 120 times the cos of 116. And that gives us 188,6. I want to show you that that value is PR squared. So PR squared is 188,6. What do we do to get PR? What must we do to that value? We must find the square root of that value, and we get 13,7. And let's just go back and see units. What units? Centimeters. So it's a length, so its PR is 13,7. Okay, so something we hadn't done earlier was to find the third side if we give an SAS. Then we want to calculate the size of TRP. TRP is this angle over here. Okay, so I begin by finding what's opposite that, 6. And I've now just calculated that 116 is opposite that new value that I found. So if the information is opposite, then I can use the sine rule. So the sine rule says that the sine, let's just clean that up, right. Right, we're just moving a little bit forward. There we go. So we've got the sine of R1, sine of R1, because remember R1 is what I'm trying to find. It's sitting opposite 6, so it's sitting opposite TP. And that will be the same as, now remember, if you're doing a sine over a side, you need to keep the other ratio in the same order, sine over side. So it will be the sine of 116, which is sine T, divided by the side that's opposite that, which is what we've just worked out, which is PR. So sine of R1 is going to be sine T, which is sine 116, divided by PR, which we've just found, which was our 13,7, which was that? 13,7. There we go. And we're multiplying it by TP, and TP is 6. So we're multiplying that by 6. So we then get sine R1 as that value, we're dividing by that, so we would like to take the reciprocal of that. And where is our reciprocal function? X to the minus 1. There it is. Okay. And then we want to multiply it by 6, and we want to multiply it by the sine of 116. And we got 0,39, and then we also want to get the angle that gives us the sine. And we get 23,1. Voila. So R1 is equal to 23,1. Okay, so that value was on our calculator. Let's just go back there. What is the sine of that? It was 0,39. Okay, so that is a 0,39 right here. Okay, so we've been able to work out that this angle is 23,1. Okay, then the size of RPA. RPA is this angle over here. Okay, now I think that's pretty straightforward because those lines are parallel, so that is 23,1 alternate angles. And finally, the area of that whole trapezium, well, we've got the green triangle and we've got this pink triangle, and we would work out the area of the green, side angle side or side angle side, and then we would work the pink one side angle side, because the area rule we can only use with the side angle side. So this area over here would be 6 times the 10. Now let's do the green one first. So if we do green area, green would be 6 times 10 divided by 2 times the sine of 116. That would be the green area, which would be 30 times sine of 116, and that would give me 26,9. That would be the area, and the pink one would be the 13,7 multiplied by the 15 divided by 2 times the sine of the 23,1. And that area would be 13.7 times 15 divided by 2 times the sine of 23.1. And that area would be 40,3. And so the total area would be the sum of those two values. Over to you, Queen.
Oh, wow. That seems like a lot to take in. But I hope you guys are still with us, grade 11s. I hope you're still following Dia and what she has been doing for us. And guys, it seems like there's a bit of a problem with the challenge question, but we will fix that soon after the break. By the time we come back, we'll have it fixed for you guys. And guys, remember that in collaboration with our Mathematics Mondays, we've got this really super cool mathematics app for you guys, and it's called MoMath. So if you guys want to find out more about it, all you can do is just simply go onto our Facebook page. We've posted all the details there. It's a really cool mathematics phone application that you guys can check out. And you can also get to see how you are doing compared to the other mindsetters. So please see yourself that you get that on your cell phones. But for now, let's take a quick ad break, and we'll see you after the break. Welcome back, grade 11s. Hope you guys are all ready for the next part of the show. But before we get straight into it, let us congratulate our second Casio calculator winner, and that is Mpomolo. Congratulations, Mpo. You've got yourself this awesome prize, and it's coming your way. So if you've just joined us, don't despair. We've still got a few more questions to go through. And Dina, can you please continue with the lesson?
I'm sure somebody's trying to get that question up on the page.
Yes,
So
yes.
I'm going to give you like 2 minutes to try the questions out. That's why our page was so
Definitely.
quiet. You didn't have the question. You were wondering, when's the question arriving? Well, we're working on it as we speak, so maybe you'll get a little bit of time and then we can have a look at it together in a moment. So let's go back to the question we didn't do earlier, which was the area question. It was actually C here. We had a little rhombus. There we go. We had a parallelogram and we had a rhombus. So we would like to find out what is the area of this rhombus, RHOM. So grade 11s, I am testing you. What do you know about a rhombus? What are the special properties of a rhombus? Very strange word. That's why you'll never forget it. It is a square that you have sat on, imagine. So you've squashed those angles. It's no longer right angles, but the sides are the same in length, all the 4 sides. So we've actually got a very unique property here. We've got that all 4 sides are equal. So all these lengths are 5 units, okay? And then I will divide this angle, this rhombus, to get an area where we can find side, angle, side. And if we look at it, we've got 5, we've got 55, we've got 5. So I'm going to cut this figure right down there with its diagonal. And I'm now going to be able to work out this area here. And how do we work out the area? Half of side multiplied by sine of the given angle. So the yellow area of triangle RMH is equal to half 5 times the cos of 55. Is that right, grade 11s? No. The only rule that has a cos function would be your cosine rule. So be very careful with this. I've seen so many matric exams where people stray from the formula and then you get the whole thing wrong. So be very careful that you've got the sine of 55. Okay. And then we have our little machine that's going to help us work with sine. So we've got half of 25, so 25 divided by 2, and we're going to multiply by that by the sine of 55. And we're going to get 10, comma, you flew away, 239. And that is squared centimeters. Okay? But if we work with this area as well, same area, so area of the rhombus would be that area times 2, so we get 20, 5 squared centimeters. Okay, just a note on rounding off. If I'm working towards a final answer and you've worked out part A, part B, part C, part D, you can give a final answer in its rounded version, but when you use it on your calculator, you need to use all the decimals. Otherwise, there's going to be an effect on that final value. And if you were rounding off and you had to round down as opposed to round up, and you're working with, let's say, amount of material that you need, whether it be wood or whatever material you're working with, and you've rounded down and somebody asks you how much they should buy, then you're not going to be purchasing enough of that material. So it's always very important in all calculations. There's a mathematical, theoretical way of working with these things, but there's also a contextual way. And you would always give a final answer in terms of a rounded value, but when you're actually calculating within the actual question, please just make sure that you haven't rounded off. Otherwise, there's going to be some serious error in that final answer. If we actually look at this one that I did with you, the trapezium, you would have noticed that over here, we got a 13,7. Okay? I did not use 13,7 in this value. You'll notice that you're a couple of minutes off if you do that. This value we had calculated in our first question, which was PR, I kept it in my calculator and I used that value in my secondary question. So subsequent questions, Please don't round off, otherwise you are going to get some error. Okay, grade 11s, are we ready for that challenge question? Have you had some time to get familiar with the context, number one, and then be able to apply some of the rules we've learned today to get some of those answers? Now, trigonometry is really about a powerful tool to solve triangles, but not just as a theoretical tool to be in your books. It's really a tool that assists in some kind of real life. For those of you doing architecture, land surveying, any of the navigation, flights, pathways, whatever, we do use some very sophisticated mathematics called trigonometry to be able to find these lengths. And so you need to get your head around what the context of the problem is all about, so you can be really familiar with what the lengths and the heights and the angles all are, so that then you can decide how to take that English into a mathematical model that ultimately you can use mathematics on to be able to solve the original question to that problem. So this one talks about a land surveyor. And it doesn't matter that you have never been a land surveyor, that you've never worked with the tools of a land surveyor, because most of the time the problem will be phrased in such a way that you'll be able to extract what the important aspects for the mathematics are. So a land surveyor took the following measurements from peg P of the points A and B on a hillside. So peg P is 993 meters above sea level. So you have P here, and they're on a hill. You must imagine they're on a hill, and they are 993 meters. So they take that as that measurement, and that's meters. And you then have a point A that is about 30 meters above sea level, and the angle of elevation from P to A is 10 degrees. So when you're at P, you're going to be looking up at A. So it's almost like if there's a cliff here, then this cliff just goes up above. And you now have to imagine that P, Q, and T lie in the same horizontal plane. So even though we've drawn Q and T just a little bit above that point P, it's to give us some perspective. So in the art drawing of that, P, Q and T appear to be a little bit higher, but you can imagine they're actually in the same horizontal plane if you had to be lying flat or standing flat at point P. But what we do know is that this length all the way to sea level is now 1,019 meters. Now, before I carry on, if I'm given a secondary bit of information that I can use to calculate some other lengths, and I'm going to do that. From that distance to that distance, I now can tell that just this AQ here has got to be the difference of those two. So just to be a little bit more accurate, I said 30 meters. It looks like about 30 meters to me. It would be 1,019 minus 993, and that would be 26 meters. Okay, so just this length over here is 26 meters. Then they carry on and they say, point B is 1,010 above sea level, and the angle of elevation from P to B is 8. So now, when we're standing at P, we're going to look up at another little cliff on that side, or something along that side. And this distance from there to there, actually, let's just go back. Okay, this distance from there to there is 1,010. So that's just slightly lower than what point A is. And it allows me to now calculate what BT is. So 1,010 minus 993, that gives me 17. So I know that this length over here is 17. Right, so angle of elevation, I'm looking up. That's my angle I create, my sight line with my horizontal. There's my horizontal sight line. So these triangles that have been created, it's the model of the various horizontal lines to the various sight line. I'm able to create these right-angled triangles. Okay, so the first question is, what is AQ? We've now worked that out. What is BT? We've worked that out. And this word hence, grade 11s, what does this mean? Should I ignore that? And should I carry on in my own way? Or should I be finding that word hence useful? And yes, that English word simply means you have now found some information. As a result of finding that information, use it to answer the next question. So it is important, because when they say hence, they are asking you to follow that train of thought. They're not allowing you to venture off on your own and find your own suitable way of solving this problem. They're saying, stay on the narrow path here, stick with us. You've got to use what you've just found to now solve the next question. So what is the next question? Determine the length of PB in terms of a trig ratio and BT. So we're going to find what is PB. Here's PB in terms of a trig ratio, and they want something else, and BT. Okay, so we're quite happy with that, because you've got a right angle triangle, so that's not a problem. We would like the pink line, the yellow line, and the 8 degrees to be connected, because a trig ratio just means the trig of some angle. So if I look at it, that's opposite. That's my hypotenuse. So that's pretty easy. We have the sine of 8 degrees is equal to opposite, which is our BT, over our BP. So BP is equal to BT divided by sine 8. Okay, let's just double check that. Opposite over hypotenuse, 17 over BP. So BP switches with sine 8. Multiply, divide, so it's BT over sine 8. Okay, so we now have further information. And then if it is further given that APB is 71, so where's APB? APB, okay, now you've got to really imagine that you're working in this plane here, and that this APB is 71 in this green triangle. Okay, then calculate the distance from A to B to the nearest meter. So we would like to find out what that distance is. Now, I know from the previous question that I will be able to work out what BP is. So I'll be able to work out that length. Similarly, in this triangle, I'll be able to work out this length. So grade 11s, you're very clever today. You've absorbed the whole lesson. If I've got side, angle, side, how can I work out what the AB is? What rule do I use to work out that third side of that triangle? The cos rule. That's great. That's fantastic. So we're going to use the cos rule on APB. So I'm going to draw APB down here so we don't lose the information. So here's my APB. This is A, P, B. That's 71 degrees. This length here, PB, we've worked out as 17 over sine 8, I think it is. Yeah, 17 over sine 8. So this is 17 over sine 8. And how are we going to work out this length here? Is it not the same? Opposite over hypotenuse. So it's exactly the same system as or process that we've worked with in that triangle. Opposite is sine of 10, so we have 26 and sine 10. So this would be 26 over sine 10. Right, and now we're ready for the cos rule. What does the cos rule say? The side I need first, that's where you start, AB squared equals AP squared plus PB squared minus 2AP times PB times the cos of 71. Okay, let's substitute in. So we have AP is 26 over sine 10. And we're going to square that. Plus PB is 17 over sine 8. And we're going to square that. Minus 2 AP is 26 over sine 10 and 17 over sine 8. And we're going to multiply it by sine 71. Right, let's put that all into our blender, our mathematical blender. and let's see what we get. So we have bracket 26 divided by sine 10, zoop zoop, bracket. We're going to square that. We're going to add bracket 17 divided by sine 8, sine 8, bracket, bracket. We're going to square that. And we're going to subtract twice of 26 times 26 divided by sine 10. And we're going to times by 17, and we're going to divide it by sine 8. Okay? And we're then going to multiply it by our, not sine 71, because we've just used the cos rule. How did that sign get in there? Gee, that's terrible, hey? 71. And we're going to press our equals, and then we need to take the square root of that answer, and we get, voila, 159, 5. 159, 5. And let's just correct this little sign, because that should have been a cos 71. Over to Queen.
All right, that is it. Challenge question. Well, guys, we've got a few answers from Njabule and Mantle and Kosi, and it seems that they are on the right track because their answers are AQ 26 units,
Yes.
BT 17
Yay.
meters, QAP 80 degrees, and PBT 82. So congratulations to you guys. You've got the answer right. But now, I think that is it for the show. Grade 11s, that is it for us. We're going to be wrapping up now. But don't forget that we are announcing our Sony Xperia L cell phone winner at 6 o'clock. And that is in the next show. So don't go anywhere. Tune in. If you know that you entered and you know that you stood yourself a chance to win that cell phone, then do not go anywhere because we'll be announcing that winner very, very soon. That is it from myself and Dina, Grade 11s. We will see you again next week, Monday. Goodbye.